All right, Wildcats, here we are on day 2 of our note-taking, page 60 of chapter 2 and lesson 2. We are going to do deposition. So get your red pen, come over here to our paper, and let's skip a line. Deposition, capital D-E-P-O-S-I-T for deposit, I-O-N to change it to deposition. We need our pencil. Rivers usually drop sediment they carry somewhere along their course to the ocean. The process of dropping sediments is called deposition. While erosion is a destructive force, deposition is a constructive force. It builds up the land. Okay, so they're giving us a distinction or a difference between erosion and deposition. So deposition is constructive, meaning it constructs or builds things. Constructive, C-O-N-S-T-R-U-C-T-I-V-E, force, F-O-R-C-E, equals build, B-U-I-L-D, and up, U-P. Deposition helps create a variety of surface features. Several of these features occur as part of river systems. Recall that rivers usually begin at high elevations. The water flows swiftly downhill, picking up sediment. When the river gets closer to the ocean, the land gradually levels out. This leveling causes the water to lose energy and slow down. Sediment drops out of the slower water and is deposited. So, as a river slows down and loses energy, it deposits the sediment. Okay, river, R-I-V-E-R, slows, S-L-O-W-S, comma, loses, L-O-S-E-S, energy, E-N-E-R-G-Y. Meanders and oxbow lakes. Okay, I'm thinking that we're going to end up running out of space on the front, so let's go ahead and flip our piece of paper over. Okay, meanders and oxbow lakes. Do you notice that almost looks like a little heading, but it's not colored? So let's go ahead and write that over here on the left side where all the titles go. Meanders, capital M-E-A-N-D-E-R-S, and down, 3 down, oxbow, O, capital O, X-B-O-W, lakes, capital L-A-K-E-S. So remember, we know meanders mean when the river goes side to side or starts winding and curving. Oxbow lakes, they're literally talking about the shape of a collar that farmers used to put around the neck of an ox. It's going to be this roundish shape. That is an oxbow shape. Okay? When a river moves across wide, flat regions, it begins to wind in curves called meanders. Meanders increase in size as water erodes the outside of each curve and deposits sediment on the inside. Meanders occur because the flow of the river slows down on the inside and speeds up on the outside of each curve. Sediment is deposited by the slowing water and eroded by the fast current. Oh, that makes sense. That's the same thing as when it flows downhill. It's fast and it picks up sediment, but then it slows down and it deposits the sediment. Sometimes one curve in a meander will catch up with another curve that is farther downstream. A loop forms in the river. The loop is eventually cut off by the deposition of silt and clay, creating an oxbow lake. Okay, that's a whole description of what's going on in these pictures. So what we're actually going to do is copy these pictures. Number 1, over time, erosion and deposition form a narrow neck of land in a meander. So, as you can see, we have a river, and the arrows show which way it's flowing, and it's obviously meandering a lot, right? It's curving and twisting a lot. Now, they talked about how it speeds up on the outside. The water kind of speeds up and goes faster over here, so it's fast and eroding away, or carving away that section. It's slow on the inside, so all the sand and silt and sediment deposits on the inside. So more land is building up on the inside, and more of it's getting carved out on the outside. Okay, let's go ahead and try to draw a picture. And we're going to use the entire width of our paper in like thirds. So we're going to have a picture there, in the middle, and on the right. Okay, let's go ahead and do a little curve down like this. And we'll try to draw it the same shape they draw it. we're going to draw some arrows to show which way the water is flowing, and we'll mark it flow, F-L-O-W. Up inside here, we're going to do like a little bit of shading, and we're going to say deposition, D-E-P-O-S-I-T-I-O-N. And then out here, we're going to say erosion, E-R-O-S-I-O-N. So now we can see that the water's flowing this way, it's depositing on the inside, and it's eroding on the outside. Okay, step 2. During a flood, the neck is broken through. A straight path opens for the main flow of the river. All right, so what happens is the curve gets carved out so much that they basically end up touching, and when there is a flood, whoosh, you end up getting a straight river through. Okay, so we're going to mark that that's the flow, F-L-O-W. We're going to make this big, thick line to show that that's now the new river. And then in here, we actually have an island, I-S-L-A-N-D. Okay, let's label these with the numbers they said. Number 1, number 2, and let's put a number 3 over here. Okay, number 3, deposition of sediment cuts off the loop, forming an oxbow lake. The neck quickly fills with silt and vegetation and dries up. Okay, that little part right there, that's the neck. So, let's go ahead and draw the big river and mark our flow and label it F-L-O-W. Let's draw the oxbow lake, but this time let's kind of like fill it in with the deposition, the deposits, the sediment. Okay, out here is the oxbow lake, O-X-B-O-W, lake, L-A-K-E. And then in here is going to be the deposition. So let's draw like a little arrow and say deposition, D-E-P-O-S-I-T-I-O-N. And then there is our island. That's like little bits of grass on the island. So now all these words kind of make sense with a picture. Okay, so let's read the words again. Meanders erode the outside of the curve. Okay, so meanders, M-E-A-N-D-E-R-S, erode, E-R-O-D-E, outside, O-U-T-S-I-D-E, curve, C-U-R-V-E, and deposit, sediment, on the inside. Deposit, D-E-P-O-S-I-T, sediment, S-E-D-I-M-E-N-T, inside, I-N-S-I-D-E, curve, C-U-R-V-E. Okay, let's do that labeling where they talk about when the flow is fast and the flow is slow. So erosion out here, fast, F-A-S-T, flow, F-L-O-W. In here where it says deposition, slow, S-L-O-W, flow, F-L-O-W. All right, now sediment deposited by slowing water, one curve catches up with another, and a loop forms. Okay, so curves, C-U-R-V-E-S, meet, M-E-E-T, form, F-O-R-M, loop, L-O-O-P. And then the loop can be cut off, creating an oxbow lake. So flood, F-L-O-O-D, breaks, B-R-E-A-K-S, through, T-H-R-O-U-G-H, flood breaks through, oxbow, O-X-B-O-W, lake, L-A-K-E. So now from our notes, we can describe the entire thing. Meanders erode the outside of the curves where there's fast flow. It deposits sediment on the inside of the curve. where there is slow flow. Eventually, the curves meet and form a loop, and the water is still flowing by in the river. And during a flood, it can break through and create an oxbow lake. All right, alluvial fans and deltas. Okay, that looks like another little mini title, so let's put that over here. Alluvial, capital A-L-L, U-V-I-A-L, fans, capital F-A-N-S, and down 3 down, deltas, capital D-E-L-T-A-S. Okay, we basically know what those are from our vocabulary terms and from these pictures, but let's go ahead and take our notes. When the flow of water in a river decreases quickly, special kinds of deposits are formed. An alluvial fan is a fan-shaped landmass that forms after water rushes down a steep slope, then slows over a flat plain. Okay, so we don't need to write the word, but we can draw a little picture. So let's draw a picture of like some mountains maybe, and some hills. And then what we're going to show is we're going to do like some curlies coming out down here. And then we're going to do like some flat land right there. And we're going to draw some straight lines coming out from there with arrows at the end. And let's do another one like that and another one like that. Okay, so that is an alluvial, A-L-L-U-V-I-A-L, fan. And we know from our vocabulary term on the other side, for alluvial fans, it's a fan-shaped landform. When the water rushes quickly downhill, it eventually slows down at the flat spot, and that's how it spreads out. Okay, next up, alluvial fans are common in Death Valley, California. Mountain waters suddenly slow down as they drop from steep canyons onto the flat valley floor. Okay, that sounds like what we just described and what we just drew. A delta is a low plain that forms where a river enters the ocean. Sediment that is still being carried by the river is dropped here. Deltas often take the shape of a triangle. Ah, remember yesterday when we drew that triangle? There you go. That's why in math, when they say there's a delta, they use a little triangle symbol. If the river is large, the delta it creates will be large too. The Mississippi River has a vast delta that extends into the Gulf of Mexico. Okay, so for a delta, we know that a river is flowing. And then we know that it kind of drops sediment in a triangle form. So it's very similar to an alluvial fan, but there aren't any mountains involved. It's just a river. So let's label this river, and let's label this delta, D-E-L-T-A. And then it's important that it is dropping sediment. So let's put deposition, D-E-P-O-S-I-T-I-O-N, because that's when sediment is being dropped or deposited. All right, let's look at our pictures. There's an annotation here. As a river flows across a flat plain, its course begins to wind in curves called meanders. Okay, we have that vocabulary word, and we have a picture of that. Alluvial fans and deltas are formed when rushing waters slow suddenly, and their sediments are deposited. Okay, notice it says slow suddenly. So over here, we're going to say sudden, S-U-D-D-E-N, slowing, S-L-O-W-I-N-G. So when it suddenly slows down, or there is a sudden slowing, that's how alluvial fans can be formed, from coming from a very steep place to a very flat place. So let's also write that. Steep, S-T-E-E-P, and then over here, flat. So we need to contrast, compare and contrast, that it starts out steep, but then it spreads out very flat. The Mississippi River Delta is called a bird's foot delta. Why do you think it got this name? Well, because it kind of looks like the foot of like a duck or a water bird, right? Like there's the leg, and then it spreads out and almost looks like webbing in between the little bits of the river. Okay, can we answer our main idea from our notes? What determines where deposition occurs? What determines where deposition occurs? Well, it seems like it talks a lot about the speed of things, right? Like when something is fast, that's erosion, but when it's slow, it's deposition. Same thing here, right? When the river gets to a point where it spreads out and slows down, there's deposition. And then the same thing for the alluvial fans. It's fast up here where it's steep, but when it gets to this flat land, there is a sudden slowing. So I think we would answer it like this. Something that determines where deposition occurs is the speed of the water. For example, Zoop, meanders carve out the outside of their curves, but deposit sediment on the inside of the curves where it's slow. Also, Zoop, deltas, and alluvial fans deposit sediment when their water slows down. Okay, so slow versus fast. That's a big theme. You know what? Let's put that over here in the left. Slow, S-L-O-W, versus V-S period, fast. That is a very important concept for this entire section. And that helped us answer our main idea. Okay, here's a secret. That was actually like a phase 2 thing that we just did. That wasn't a phase 1 taking notes. That was like a phase 2 processing. We just added information. So you're already doing phase 2 as we're doing phase 1. All right, that's it for today. We did all of those pages. Good job persevering with the growth mindset. And roar Wildcats!